In this video, we'll look at solving the challenge of performing analysis on streaming data using FME. Unlike data from a database or file, streaming data is unbounded. It doesn't have a defined start or end, so we have to define one. This can be addressed with time windowing. In this demonstration, we'll explore the TimeWindower transformer in FME Workbench, windowing on processing time versus event time, and types of unique IDs to assign a window. Let's start the demo. The TimeWindower transformer in FME Workbench is designed specifically to allow you to window your streaming data. You can specify the size of your window based on duration. For example, if you are reading an unbound data stream from a sensor and the data points are coming in at roughly 1 message a second, you might choose to window the data at 1-minute intervals. This means that all of the features that arrive during that 1 minute get tagged with an attribute value as belonging to that window. This gives us something to group the data on downstream for further processing. The longer you make the window, the more you can likely infer because there will be more data points in each window. However, a longer window also means more lag between receiving the data and writing out results. Define when your window should start. Window based on processing or event time, if your data has timestamps. And choose the identifying attribute for the window. Once the TimeWindower is configured, groups of features will exit the output port one window at a time. In addition, a single feature will be output from the window change port for each window change. This feature can be used to trigger a data refresh of other non-stream data needed by the workspace, in this case, getting the user's most recent location. Or other processes, like flushing data from the prior window. Let's look at two methods to window data. The first and most simple is to window using processing time. This is the only option if your data doesn't include timestamps. If choosing this method, it is important that your data arrive in event time order, since they will be assigned to the time window based on when they arrive. The second method is windowing using event time. In this case, the data must have a timestamp attribute. This type of windowing allows for greater control over the window, since there can be a lag between when an event is transmitted by a device and received by FME server. Order settings help ensure that features don't end up out of order or in the wrong window and cause problems downstream. We can order the data chronologically or reverse chronologically based on the timestamp attribute. The tolerance settings let you create a grace period for late features to be reordered and sent through the output port. When data is ordered chronologically, features that arrive late and outside of the window's tolerance settings are sent to an out-of-sequence port so they can be dealt with downstream without compromising other data processing. There are 3 types of IDs you can assign to all features within each window of data. Window number will assign an integer sequentially based on the time that has passed. Window start time will assign the window start time in Unix epoch time. Window end time will assign a time also in Unix epoch time. The ID chosen is what data will be grouped and processed by downstream. This sample workspace receives a constant data stream of driver locations from Kafka and determines driver proximity to a user's location. To learn more about this workspace, check out the article Spatial Data on Unbounded Data Streams on the FME community. In this example, the TimeWindower assigns a window number integer to each group of features in the window. While running, we can check the logger's output to see the window ID increment as each window is processed. To see more examples of the TimeWindower in action, please check out the other stream processing videos on this channel. Follow Safe Software for more quick stream processing demos and check out the FME community for in-depth tutorials and webinars.